Hello again, customers. Just doing another video of this large project that we're doing in Hannibal, Missouri. I told you on the last video that we were going to do something about ice and water shield. We've covered ice and water shield a lot. The reason why we cover it so much is because we don't see people utilizing it correctly, whether that be on roofs that we tore off, which could be that the material didn't exist then or it wasn't a code then, or lack of knowledge, and hopefully the least of which basically being deceitful. So we want to make sure that people are educated about ice and water barrier, so that way when they're having the roof project done, whether it be Right Rate Roofing doing it or another contractor, they're able to hold them accountable. I'm not going to get into the measurements today for what ice and water should be for a code, but just talk about two different styles of ice and water barrier. And we're talking about it on this copper system here. So we're halfway through this copper system. It's a copper dormer. And I'll link I'll put a picture in the comments of the other side of this garage that is a completed portion of this. So what happened here there's 4 dormers on this house, and just similar to this one, there's one exactly the same on the other side, and there's 2 similar on the house. What has happened on this was the copper did fail on the top portion. One of the welds failed, and the material that was underneath of there was a normal organic felt paper. Organic felt paper is a lot like a soft shell jacket in that it's water resistant, not waterproof. The organic material in it, the ground wood fibers, allow for it to actually absorb water and degrade over time, whereas in synthetic products can also degrade, but just like plastic, you know that they degrade at a lot slower rate. So when you have a leak or water backup due to adverse weather conditions, having the appropriate underlayment for when your main barrier failed, even if it's a material like copper that is a forever product but has the potential to fail, you want to have an underlayment that can withstand the test of time if there was that failure. Now, obviously, the first step is to get it done right, but you can't account for the things you don't know. So a lot of times, ice and water shield can be used in areas where there is more potential for a failure, not because of incorrect installation, but it could be due to adverse weather conditions. Even if a failure only happened once every 20 years, that's still inside the lifetime of that roof system, and that failure could be catastrophic. So not that everything we want to do, we want to base on the what if scenarios, but for the most part, that's what we want to do. So in this situation, we knew that we needed to use an ice and water barrier because it's towards the eaves of this roof system. But if we went with a normal ice and water barrier, which I have a little sample right here. So this right here is our normal Owens Corning Weatherlock ice and water barrier. As you'll see really close, it's a granulated material. It has a self-adhesion on the back, so it sticks to the roof and binds itself to the roof. So this material is self-sealing. The granulation helps us walk on it, so it makes it a really nice material for installation. However, the ratings for that material are normal ratings. So it's not to be used in a high temp situation. So like, let's say, in Arizona where you're putting a tile roof on, I don't think that you'd want to use that ice and water barrier. You're going to want to use a different style of ice and water barrier called high temp ice and water barrier. In this climate, when you have a copper roof or a metal roof, right, an exposed fastener or a standing seam, anything like that, you're going to have extreme temperatures in that area because it's going to make it like it's an oven, right? And there's not going to be the ventilation. We're going to solder this whole copper portion here, so it's going to basically create an oven. And what happens when you have a material like this asphalt material in those higher temperatures, it's going to melt it. And I was actually just at home earlier this summer in Quincy, that there was tar dripping from the corner of the valley of this roof, and they're like, well, we keep wiping it away, where's all this tar coming from? The customer did not want to go forward with the repair at this time because of the expense associated with it, but so I wasn't able to tear it off to totally identify that, but I'm very confident it was facing south, gets a lot of sun in the summertime, that there was a lower temp or off-brand ice and water barrier in that valley that was causing it to melt the ice and water barrier and drip out as tar at the bottom corner. So very important that if you're putting metal over top of ice and water barrier, that it's the correct temperature tolerances. With that, there's granulated and non-granulated. So if the type of material you're using is being fastened directly to the ice and water barrier, just like this is, right, going direct on the top, we don't have any one bys or anything like that we're attaching to where there's a space. We're also going to want it to be non-granulated. So if you look at this sample that I have here, it's also a self-sealing membrane, right? And that's what we utilize in that space. Similar thicknesses, but this material is a high temp ice and water shield. So this and this is not. But this, you notice, is not granulated, and this is. So the reason why we want to go with a non-granulation, and this is kind of like the what if brigade, is that as the panels expand and contract, it's as the metal material expands and contracts, over time those granules can actually wear out the back of the surface. Now, I'm not 100% sure on how that would work with copper and if it would actually eventually wear out the copper. I think the shingles on the roof would wear out before the copper did. But in the situation with exposed fastener or a standing seam roof, if you had a granulated material there, most of those panels have a coating on the back that protect the panel from rusting out from the inside out. And when you put that on, like directly over asphalt shingles or over top of a granulated ice and water barrier, it causes that coating to get scratched up. Not that it's damaging the panel, but it's causing the coating to scratch. And then once condensation happens, which is natural between hot and cold surfaces, like a hot panel or a cold panel on a warm exterior decking, that condensation would then cause the panel to rust and rust from the inside out. So I just wanted to do a video about the differences between regular ice and water barrier, because we talk about it a lot, and high temp ice and water barrier, which should be what's being used underneath metal, whether that be copper or a standing seam or exposed fastener or aluminum. And then also to take it a step further, the difference between granulated and non-granulated and when you should use them and what the purpose of those are. So if you have any questions about this, or it's something that you'd like to discuss, or you have questions about this project specifically, you can definitely reach out to us through our website at the Contact Us, and there's a link in this description. You can also reach us at our office phone at 217-779-7663. Thanks. Have a good evening.